So f is defined in the following way. Find the values of a and f of 2 in order that f of x may be continuous at x is equal to 2. Alright. So basically the condition for continuity, we know that it is the left hand side limit should be equal to right hand side limit. So first let's start by finding out the limit of this function with respect to 2. So it will become a 1 minus cos x by 2, and we know how to solve such functions. To get the standard form, we divide and multiply by x minus 2 square, because as x tends to 2, x minus 2 will tend to 0. So we will have a standard form, that is cos 1 minus cos theta upon theta square with theta tending to 0. We know that that is half. Let's write the remaining terms as well. It is x minus 2 and tan x minus 2. Okay. So as I said, in the limiting condition, this whole thing will become half. X minus 2 cancels out with one of the x minus 2, and this whole thing will become 1. Even this is a standard formula. So finally we are left with the limit in this case is a upon 2. Now let's move on to this part. So first let's just write the whole thing properly because it's a huge expression. So it is e raised to x plus 2 ln 4, and okay, so if we have taken x just less than 0, because it is given x is less than 0, so then the greatest integer function x plus 1 will be just less than 3. So the value of that we know will be just 2. So 2 upon 4 is 2. So this whole thing will be raised to 1 upon 2. 2 upon 4 is just half. So this whole thing will be raised to 1 upon 2. This minus 16. Okay. This is our numerator. Let's solve it. Let's simplify it. So writing ln 4 as 2 ln 2, it will cancel out with half and 2. So we are left with e raised to x plus 2 ln 2, and this we can just write as e raised to ln 2 raised to x plus 2. So we know that this will basically become just this value, and that is 2 raised to x plus 2. And we also have a minus 16 over here. So let's rub this. It is basically 2 raised to 2 into 2 raised to x. So 2 raised to 2 is 4 into 2 raised to x, and then minus 16. And now let's check out the numerator, the denominator. It is 4 raised to x minus 16. So let's write that in the form of a square minus b square. So a square is 4 raised to x, so a will be 2 raised to x, and b square is 16, so b will be 4. So in the denominator, we can write this as 2x plus 4 and 2x minus 4. Now in the numerator, you will observe that if we take out 4 in common, we are left with 2 raised to x minus 4. So this will cancel out with this, and finally we are left with just 4 upon 2 raised to x plus 4. Now in the limiting case where x is tending to 2, it will become 2 raised to 2, so 4, 4 plus 4 is 8, so 4 upon 8 is equal to half. So this is the limit in this case, when x is less than 2. So for the function to be continuous at x equal to 2, both of these limits should be equal to each other. So half is equal to a by 2. That just means clearly that a should be equal to 1 and f of x is equal to half. So these are our answers.